Good evening, everyone. We are the Group 1, and today we will discuss our case study about light transmitting concrete using eco friendly materials or waste materials. It is conducted by A. Jayaraman et al., and the name of the journal is International Journal of Chemtech Research. It is published on 2020. Next. Good evening, everyone, again. I'm Kevin Angelo Amparo. I'm tasked to discuss the introduction of the study. So, this paper contributes to the determination of new alternatives for sustainable construction. Light transmitting concrete or LTC can help reduce power consumption in buildings by allowing natural light to shine through external walls. The main aim of the project is to develop the green environment and the concept of green building. Additionally, another aim of the project is to develop the compressive strength and tensile strength in various grade of concrete and replacing in various percentage of glass powder. With this, we can reduce the land pollution by recycling of waste plastic aggregate. Next.
Good evening, everyone. I am Kit Gerald D. Ilias, and I will be tackling about the statement of the problem. So in order to address problems whether using scrap materials were deemed effective as replacement for manufactured aggregates, an attempt will be made to provide answers to the following pertinent questions. Number 1. By comparison, what is the compressive strength of the conventional concrete mix and the fully replacement of glass sand and plastic coarse aggregate in 7, 14, and 28 days of curing? Number 2. By comparison, what is the tensile strength of the conventional concrete mix and the fully replacement of glass sand and plastic coarse aggregate in 7, 14, and 28 days of curing? Next.
So good evening everyone, I am Mervunibar A. Valermo and I will be discussing the objective of the study. First, the light transmitting concrete panel's primary function is to conserve energy by utilizing natural light and it is being produced as a green building material. Number two, due to the current lacking of both coarse and fine aggregate, we substitute them with waste plastic and glass bottles are both common in the environment. And lastly, the project's primary goal is to use the eco-friendly methods to lower concrete's light transmission and member weight, environmentally friendly waste and optical fiber. So this will be our the methodology of our study, and I will be also discussing the materials that are being used in this study. First, the ordinary Portland cement or the OPC. Ordinary Portland cement of 53 grade available in the local market is used in the investigation. The current use has the cement used has been tested for various properties as per IS 12269 to 1997, having high specific gravity of 3. So the table below um, shows the physical properties of the cement, also the chemical properties of the cement. Second, the glass sand. It will be replaced for the fine aggregates. We collected all the waste glass bottles from the various locations and crushed them in the laboratory using the compressive machine and the impact testing machine. So glass aggregates can be used in replace of sand and gravel in concrete and created effects ranging from the colorful terrazzo to granite or marble-like finishes to concrete that reflects light like a mirror. So in the right side of the image below shows the actual image of the crushed bottles or glass sand, And the table below shows the physical and chemical properties of the sand used in the study. Next.
So let us tackle about the plastic aggregate or the replacement for coarse aggregate. So coarse aggregate is the strongest and poorest component of the concrete. Presence of coarse aggregate reduces the drying, shrinkage, and other dimensional changes occurring on the account of movement of moisture. In their place, we melted plastic bottles and made like coarse aggregate by 20 mm. Whereas the plastic coarse aggregate can lower the concrete slab weight. So in our project, we use plastic aggregate. So the table below shows the physical and chemical properties of plastic aggregate and its values. So in the right side, this is the actual image or picture of the plastic aggregate. So next is the plastic optical fiber. So plastic optical fiber or POF or polymer is an optical fiber that is made of out of polymer. POF transmit light for illumination or data. Through the core of the fiber, its chief advantage over the glass product, other aspect being equal, is its robustness under bending and stretching. So the table below shows the basic properties and the values. And in the right side, you can see the image or picture of the plastic optical fiber. So the last method of our study is the experimental procedure. So the mix ratio is prepared for M25 grade concrete for both conventional concrete and bottom ash and lateritic sand mix concrete. So the cube size of 150 by 150 by 150 mm specimen is prepared for compressive strength. So the cylinder of height 30 cm and 50 cm diameter is prepared for tensile strength. So the specimens are tested for 7 days, 14 days, and 28 days with each proportion of waste glass sand, waste plastic materials, coarse aggregate, and optical fiber mix. So totally there are 18 cubes and 18 cylinders are casted. So the panel size of 0.5 by 0.5 by 0.1 meter is used for light transmitting concrete panel board. All the specimens are demolded after 24 hours and curing is done in water for 7 days, 14 days, and 28 days. So by the way, I am Michael Jan Yusantan and good evening. So next slide.
Good evening, everyone. I am Joshua James S. Selosha, and I will discuss the results and findings of the study. Uh, for compressive strength of the concrete, the test is carried out in accordance with IS 516-1959 to determine the compressive strength of concrete after 7 days, 14 days, and 28 days. The cubes are tested on a helico compressive testing machine with a capacity of 1,400 tons. The results are shown below on the table. When compared with the conventional concrete, the compressive strength of waste material concrete is 13.65%, 10.53%, and 5.09% lower after 7, 14, and 28 days. Next. And for our tensile strength of the concrete, the test is carried out also in accordance with IS 516-1959 to determine the tensile strength of concrete after 3 days, 7 days, 14 days, and 28 days. The cylinders are tested on a helico compressive testing machine with a capacity of 1,400 tons. The findings are shown also in the table below, which the tensile strength of waste material concrete is 15.068%, 19.50%, and 8.09% lower after 7, 14, and 28 days. And that is our result and findings to our studies.
And now let's go through the conclusions. So with thorough observation from the material testing, the study would therefore conclude that the usage of the recycled waste scrap materials would be beneficial as it would reduce all types of pollution known to man. Additionally, the data from the material testing and comparison between the conventional concrete mix and the fully replacement of glass sand and plastic aggregate was nearly identical. Using the said material would also help illuminate if used in subways during daylight, speed bumps, and lane markers in roads. So that would be all, everyone, and thank you for listening. God bless.